Hey everyone. So let's talk about generalized correlation equations in this video. So this area of subject is started by Kenneth Pitzer, who is also a physical chemist from University of California. So compressive vector as we know it only requires two parameters, which is reduced pressure and reduced temperature. But this is wrong. It's a wrong concept to think. It is because you are ignoring the fact that different type of substance would exhibit different properties. So a third parameter is required besides this to account for the different characteristic of molecular structure. This is called eccentric factor, introduced by K.S. Spitzer to overcome this problem. So if we plot the log 1 over PR saturated and 1 over TR, we will it is generally that every fluid will follow a straight line. And in particular, the simple fluid will pass through the point -1 and TR 0.7. Since simple fluid is quite simple, so we use it as our reference point. So the omega is equal to 0 by default for simple fluid. And then the omega for other than simple fluid is calculated by using by finding the difference of the log PR saturated at TR 0.7 minus the 0.1. 1.0.
The correlation for Z is according to this equation, which is Z equal to Z0 plus omega Z1. The omega is the eccentric factor. Z0 is the data base based on the simple fluid, while Z1 is needed with omega, which is the eccentric factor to account for different types of fluid. For this equation, Z0 and Z1 actually is the function of both TR and PR. For simple fluid, eccentric factor will become 0, hence Z0 will become identical with Z. Pixel coloration is only available to nonpolar or slightly polar fluid. So if we use the polar fluid, it will become a big error. To visualize the table, we plot this 3D graph using the Excel. So at the discontinuity of the graph, it is the liquid-vapor equilibrium.
So we can use the Lee-Kessler table to find the value of Z0 and Z1, but it might be difficult to find the value between it as we need to interpolate. So we can use the analytical solution as stated above. For B, which is second virial equation, which is proposed by the Pitzer correlation, we can find the value of Z0 and Z1. We can find the value for B0 and B1 using Abbott equation as shown. But this method of analysis is valid for low to moderate pressure only. For high pressure, we can use the Pitzer type correlation C.
The molar volume of liquids can be calculated by this equation. However, this equation often not of high accuracy, or by using the Lee-Kessler correlation table, but this table is valid for nonpolar and slightly polar fluids. Thus, by using the equation proposed by Racket, or by using the graph of generalized density correlation by Daubert and co-workers to find the molar volume. The reduced density is equals to density over critical density or critical volume over volume. That's all. Thank you.